Assalamualaikum warahmatullahi wabarakatuh. Good morning. I'd like to say thank you for coming in my presentation. My name is Aswasir Hasana. I am from Institute Technology of PLN Jakarta. In this opportunity, I would like to present about energy efficiency comparison in heating water using gas, electric, and induction cooktops, and determination of container emissivity coefficient. First, I will explain to you about introduction. Investigating energy efficiency in cooking using induction and other cooktops still an interesting study nowadays, since it depends on many factors such as interaction between various types of cooktops and pans, size of the vessel, and cooking mode of the appliance. In this work, we perform observation of 3 different cooktops: electric, gas, induction, in heating water from nearly room temperature 30 degrees Celsius to about 90 degrees Celsius at the place with elevation about 8 meters above sea level Jakarta. A model is developed in this work to produce temperature T time T relation, which contains some parameters. Then experiments are performed to get the same relation for different types of cooktops. The model experiment result will be plotted in the same graph to get the parameters. Experiment: a stew pan with diameter and height about 20 cm with mass of 1.315 kg filled with 1 kg of water is used in the experiment. The pan is heated using 3 different types of cooktops: electric, gas, induction, as shown in figure 1. A thermometer is attached on the stew pan for measuring the temperature. Time T is recorded at each increase of temperature about 10 degrees Celsius. For electric cooktop, current and voltage are measured using clamp meter. There are 4 types of experiments performed in this work as shown in table 1. For gas cooktop, mass of the 12 kg gas cylinder, MGC, is measuring every time the time T for temperature T is recorded. The difference between two succeeding observation time, T and T plus delta T, will give mass of M gas, the gas used during the time interval delta T. Each experiment is repeated 5 times. Related to this pair, the 5 times repetition and observation of time T for each increase of temperature T about 10 degrees Celsius are already a common practice. Result and discussion. Ambient condition. Experiments are performed in Physics Laboratory, Department of Electrical Engineering, Institute Technology PLN, Jakarta, with following ambient condition. Parameter: initial pressure 759 mm Hg, initial temperature 29 degrees Celsius, final pressure 759 mm Hg, final temperature 29 degrees Celsius. Water temperature measurement. At time 0 second, the initial temperature is recorded, and at each increase of temperature about 10 degrees Celsius, the time T is recorded, where the result for different type of cooktops is given in figure 2. Even we know that from figure 1 that gas cooktop had the water in short time, but it doesn't tell it has the highest efficiency among the 4 experiments observed in this work. In the experiment using as cooktop time T and mass of gas cylinder and its content M gas plus T, are recorded at every increase of water temperature of 10 degrees Celsius, where the results are given in quick lab. There are 5 repetitions. From this result, we can have gas mass and gas that is used to heat the water and raise the temperature every 10 degrees Celsius, as shown in figure 3, right, which is the average of 5 repetitions. From this, we can have the energy produced by the gas cooktop Qct equal Q gas, which is given in figure 4. Figure 4, total energy left and energy difference, right, produced by gas cooktop at temperature T. Figure 4 shows similar trends since the relation between total gas mass M gas and total energy produced by gas cooktop Q gas, which is simple a number and doesn't depend on the temperature T. The energy difference delta Q gas at temperature T in figure T left, where delta T equal 30 degrees Celsius, we saw that at time range delta T, that the temperature increase above delta T, the energy produced by gas cooktop is not constant, but fluctuated between 100 to 150 kilojoule. Cooktops power and produce energy. For electric and induction cooktops, they have already information of power delivery by the appliance, which is assumed to be true. The delivered energy varies. From figure, we can have the energy efficiency for every cooktops and model that are used in this work as given in table 3. Stupid emissivity. We can have a model of water temperature T, exposure of time T, where the results are given in figure 6. Area of stupid shall be quadruple from usual dimension and emissivity of polished stainless steel, which about 0.16, so 0.3 to fit the data. Time step delta T is chosen to 1 second. Every cooktop has different value of kilos, which are 250 joule to electric, 9,950 joule to gas, 150 joule to induction 1, and 250 joule to induction 2. We call address this loss to other factor as air convection from surrounding. In the future work, we plan to prepare the air convection by putting the system inside an insulation chamber as described in future plan subsection. Conclusion. For 600 watt induction and electric cooktops, we have energy efficiency about 67.24% and 56.29%, where each requires 708 seconds and 932 seconds to heat 1 kilogram water from 30 degrees Celsius to 90 degrees Celsius. While for 1200 watt induction and full flame gas cooktops, the efficiency are 74.03% and 38.55%, with required time are 332.4 seconds and 250.8 seconds to hit the water. Emissivity coefficient can be obtained about 0.3 but has not yet been considered with literature. Thank you very much for your great attention, ladies and gentlemen. Thank you for listening. My audience, we have shared the benefit for all us. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.